So our last speaker, I would like to welcome Christoph Garbe from HD Vision Systems. And Christoph is going to talk about pick and place of complex metallic parts with light, field, and AI. The floor is yours.
Great, thank you very much. First of all, I'd like to thank you for the opportunity to being able to present what we are doing, for all of you sticking out to the last talk, and of course for the opportunity of the Messe Stuttgart to host this event at all and being able to meet in person again. This is really great. So I'm going to talk to you a little bit about pick and place for complex metallic parts. We are striving, or we are enabling complex systems by using a light field-based approach in combination with AI to really enable our customers with no experience in image processing or AI to deploy this system very efficiently. HD Vision Systems might not be known by all of you, so we are a startup. We founded the company in 2017. At this time, we are 22 experts working in different topics, ranging from machine vision to robotic kinematics and engineering, to really be able to produce the complete solution to our customers. And we are located in the nicest part of Germany, Heidelberg, not too far away from you. So I just suggest to all of you, if you travel back to Frankfurt, to stop by and not only visit us, but mainly visit the Heidelberg Castle. So I've talked about light field imaging. What are the advantages of this? What you can see here is a toy scene with complex parts ranging from aluminum parts to plastic parts in a little toy scene. And if you look at this with the standard technology, you see a very sparse map where you see only part of the scene, which makes bin picking, for example, or handling tasks fairly complex. And in contrast to this, in our light field approach, you can see that the maps are much better. The quality of the data is much more advanced than standard technologies. And this enables us to really solve applications that are very challenging with standard technologies. So the key benefits of our solutions, of our products, are that we have superior results on glossy and very complex objects. We have a very high precision on these parts, and we are striving to use these advantages to be able for our customers to really employ them into their production by offering a very user-friendly system. So we are very customer-centric in this respect. We are working right from the start with the people using these systems right on the shop floor and getting the feedback, integrating that into our products to have really a system that can be used by anybody in the production process. The system itself is very small and very compact. It has about 11 by 11 centimeters in size, so it can be integrated on the robot or off the robot very easily into the systems. The integration does not stop there. We have a wide range of interfaces ranging from Profinet to Ethernet protocols, and we have a very high depth of field made available by the light field technology. So it is very easy to deploy. You don't have to refine it too much to your applications. We have 3 systems for different working distances, and they can be employed very easily into the system. We are integrating the technology together with an AI approach for advanced object handling, and this has a number of advantages. First of all, we can pick parts that are not known to the systems before. So these can be transparent objects, dimensionally unstable objects like bags, or objects where you don't have any cut data or that are not very similar to any cut data. We allow our customers tools to really retrain the network to have a very easy and intuitive approach for teach and produce. So in the process of teaching the system, you're producing at the same time, so you train the system on the fly. And we are combining very high precision of the 3D light field imaging approach with an AI-based 2-day object recognition approach. An example of this can be seen here. So we are picking syringes, for example, that are transparent and that can have different sizes, different shapes, and different forms. and they don't have to be taught individually, but they can be trained by the same network, giving you a very fast deployment for a wide range of products. There's an example of the results. So we pick the best best objects or best syringes in this case that can be picked automatically by the system. And not only do you find the objects, but you can find it oriented, so you know exactly for your following processes how to put it into subsequent processes. The same is shown here, for example, for very flexible bagged goods. So beforehand, you don't know what the objects will look like. You don't know where the top is, where the bottom is, and this can be trained with the artificial intelligence. Again, we find objects, we find the shapes, we find the picking points, and we find the orientation of these points. And this can then be retrained by the operator on the fly. So if some bag is not recognized initially, it can be very easily drawn an area around it. It can be picked by the robot immediately, and the network is retrained. Oops, I'd like to go to the next slide. It's not, oh, there it goes. So we have deployed the systems with a number of well-known players, ranging from automotive suppliers to integrators. And yeah, thank you for your attention. If you have any question, I'd be happy to answer them.